Okay, guys, so we're going to go ahead and continue on where we left off. So this one's going to have an infinite number of solutions. So we're going to ref this. Notice I've switched rows 2 and 1 already in my matrix because we're allowed to do that, and I didn't want to have to write a step for that and write it twice. So let's go ahead and do our steps, our process here. We have a 1 in this position, so we want to make these two zeros. So let's do that. We want to do -3 times row 1, add it to row 2, yields row 2, and then we want to do -2 times row 1, add it to row 3, yields row 3. So 1, -1, -2, 2. We're going to do -3 times this row I just wrote, and we're going to write that right next to it. We have -3 times 1 is -3, -3 times -1 is 3. -3 times -2 is 6. -3 times 2 is -6. And then the next one, we're doing -2 times row 1 again. So -2 times row 1 is -2. -2 times -1 is 2. -2 times -2 is 4. -2 times 2 is -4. Now we're going to add those respectively to rows, this row and this row. 3 and -3 is 0, which is what we wanted. 3 and -4 is -1. 6 and 4 is 10. And -6 and 7 is 1. Okay, so that's that. Next, we are going to have the following. We have -2 and 2 is 0. 2 and -3 is -1. 4 and 6 is 10. And 7, no, I'm sorry, 5 and -4 is 1, which is good. Okay, so we've gotten that far. Now we notice these bottom two rows are multiples of each other, so let's just multiply by -1 to row 3 and add it to row 2. And actually, we'll do -1 times row 2, add it to row 3, yields row 3. So we're going to do that, and how we're going to do that is we are going to just change the sign of everything. And now we have 1, -1, -2, and 2. 0, 1, -10, and -1. And this row is going to be, okay, so I've done 2 steps technically. I've done -1 times row 2, and then I'm doing -1 times row 2, add it to row 3. So this is going to be 0, 0, 0, and 0. Okay. And now it's not in RF form because we still need to get rid of this, so we can do that. Let's add the 1. Let's go row 2 plus row 1, yield row 1. So we're going to have 0, 1, -10, -1, 0, 0, 0, 0. And 0 plus 1 is 0. -1 plus 1 is 0. -10 plus -2 is -12. And -1 plus 2 is 1. Actually, no. Oh, yeah. We're good. I'm just adding these ones and these ones and these ones. Okay, that's all I'm doing is adding those. Okay, now let's get we know this is going to have infinitely many solutions. So we have the equations x plus, not x plus, x minus 12z is equal to 1, and we have y minus 10z is equal to -1. Okay, now it's in our best interest to choose z as the free variable here, because if we choose y, we won't be able to write x and y in terms, or x and z in terms of y. And if we choose x, the same thing will happen with y and z. So let's say z is equal to t. So our solution is going to be anything that is of the form y minus 10t is equal to -1. So this is going to be y is equal to 10t minus 1. And then x minus 12t is equal to 1 is going to give us x is equal to 12t plus 1. 12t plus 1. And so this will be our solution. Anything where you always pick t for your variable to be some number, then plug it into the other ones and figure out what the other ones equal, and that ordered triplet will be a point or a solution to your system. What this means, guys, is that instead of, so what you have happening is these are two planes meeting at a line, and so you have these, I mean, I'm not the best artist, but you have a plane, you have another plane, I'm sorry, I'm running out of space. Those should be flat surfaces, but what you see is that they meet at exactly this line here. Another way to think of it is, think about the walls in your bedroom. The wall, and look towards the ceiling. If you have a flat ceiling, you'll have a line that runs all the way across the wall and the ceiling, and that is what you're kind of looking at in a three-dimensional space. You're looking at two lines that intersect, or I'm sorry, two planes that intersect at one line. Okay. And so that is your infinitely many solutions, and they all fall on this line here. Okay. So let's keep going. So notice we got the same values there. And I would do more of these, but it's going to be literally the same thing. We're just going to ref, and we are going to write these in terms of if they have a solution, we're going to say they're consistent and get the solution. That would be, if you got one answer, that would be like what we did last week. If they're inconsistent, you're going to have 0, 0, 0, or a line of zeros on the bottom that is equal to something other than 0. That would be inconsistent, no solution. Or you're going to have 0, 0, 0 equals 0 on the bottom, or 0, 0 equals 0, some row of zeros completely. And you'll be able to make a free variable out of one of the variables, and you will be able to determine different solutions or infinitely many solutions that solve that system. And so I hope this helps you guys with the inconsistent thing, guys. Just watch the videos on Gauss-Jordan elimination. Notice it's this. I'll write it out. And if you watch the videos either from last week or this week or the next one that I'm about to make, because we use that to do inverses sometimes, then you will still be practicing. You'll still be able to get the results you want. I don't really see the point of me just doing like 80 examples of Gauss-Jordan elimination when you can watch a video over and over again and kind of see what I'm doing and hopefully pick up parts and practice it on your own. Obviously, what I want you to do is do the student practice that's associated with this and try to get the answers to them. I know that there are ways for you to do this and to get practice in, and make sure you're doing your ALEKS homework. So that being said, thank you guys for watching. I'm going to get going on the next video here in a second.